Sorry for that. Okay, before we start the actual process, I wanted to say a few words about how we work overall. So we use agile methodology such as Scrum, which is
Go on.
okay, which is basically means that you should not plan ahead all of your development, but divide your work into small chunks of time, like 2 weeks probably, and plan for it. Do it only 2 weeks, and then probably rethink what you do next. So it's more flexible. And it's vital in web development. So, all right, next one. So client's request, how it looks like. Practically it looks like this. It's a small and simple example, but it's pretty like in life. So what you should figure out with client before they start development, like it's very, very crucial to avoid these problems in future. Like first of all, you need to figure out scope. In this example, it's very easy. It's like feature 1, 2, 3, and 4. Like, time. It's very important to know your time frames. Here we have like 2 months. So it's important to know when you plan ahead. So you have no more time. So you need to probably minimize the scope to be in time. Then of course budget. Design, if it's needed or not, how much design, how well should be things designed, do they need like product design or only UI? You need to figure it out first. And criteria of acceptance, which becomes most people like usually people forget about this, but when release came, it's like you should better do it before starting of development. Criteria of acceptance is basically how would client know if feature is ready or not. For example, he should say like it should work. I don't care how it looks like. It should just work. So it's kind of criteria of acceptance. Okay, so we figured all the things out with clients. So what we should do next? First of all, you choose a team. You create a team in common case. Hey, okay, in common case, it's all kind of specialists like backend, frontend, design, project manager, and quality assurance. But it depends on project, of course. If project is small enough, it could require only like backend developer, for example. Maybe it doesn't require design at all. Maybe it doesn't require QA because client has it on their side. So it depends on the project. So when you gather the team, you start to estimate your scope of work. This basically means that you should take the scope your client provided and divide it into features and figure out how you would develop them. Better to do it in detail, so you would know all the risks. You will know like all the questions that may rise during the development. So and basically the outcome of this stage is somehow communication to your client okay, so we can do this in your time frame and budget, we can do this, and this. It will look like that. So we have several questions, answer them please. Okay, these are our suggestions, these are the risks that we take. So something like that. After that, if client is okay with that, we're creating backlog. It's more detailed description of every feature, but it's practically like the stack from which we will take our tasks to develop. Okay, and if the design is needed, it's the best practice to start design about a month ahead of development, because it could, if you would need to rework something, it could take more time during the development than in the beginning. So it's better to do before starting of development. So okay, you did all of that, and then the fun begins, development.
And this previous part was mostly taken care of by the project managers, but the whole team takes take action in that piece. And in here, I will give you some sneak peek into what actually the developers do. And the sprint 0 is something because the sprints basically are just chunks of time, like 2 weeks or 3 weeks, in which we agree that at the beginning of sprint we just deliver this and that, and we try hard to do this. But we don't estimate for like a half year into the future, because this is complex and will never work. So basically we try to keep the sprints as short as possible. And the sprint zero is something different. It can be like just a week or a few days, depends on the project. And it's basically a time that no feature is developed during this sprint, only the so-called preparations. And this includes the basic app setup, in our case mostly just Rails new command, and some standard gems. Like we have a set of things we usually include, like device for authentication, that sort of things, and the test setup. So from the day one we have just one test that answers like 1 = 1, but it all has to run correctly and pass. And before we move on to the next point, one might say that why to do this again and again. There are some ways to automate that using some new application templates, those sort of things. And if we were starting a new app every 2 weeks, we would probably use templates. But since we have like 3 or 4 new applications a year, really, and the community, the Rails environment changes so frequently that those templates just get outdated very quickly. And this beginning of a new project is a perfect moment for revisiting our best practices, see if there may be some other new gems that will work better, something, what's new in Rails itself. Like we're starting with the least stable version possible. So those kind of things are just goes into the sprint zero. And also some very early database architecture, just focusing on the next couple of sprints of features, like how it could look. But just very briefly, it's not like we are spending 2 weeks of writing UMLs. We never did something like this. What's more, like some kind of like services setup. So like GitHub, because we have our own accounts, customers have their own accounts. Sometimes there's already another team that will work on some parts of app and those kinds of things. So like all the access to code base, etc. And what is very important, the continuous integration that will run our tests. And we want to have this from the day zero, basically. That's why we do all this setup that really tests nothing, but it's already working, and we can see that, okay, you have a green light, so everything is going fine. Also, in a sprint zero, research, because every app is different, and we don't obviously know everything at the very beginning, and also some prototypes, for the same reason, basically. And here you can see a screen from GitHub, and this is actually the first commit, and then the day one, basically. What is the very good practice is that after you type in Rails new, just make a commit, so that every change, I mean, someone can see what's the difference from the stock Rails app. So yeah, that's basically how it looks. And as for the prototypes, I have a small example that we're making an app that was supposed to schedule people in projects. And those words represent hours, and the lines are just users. So we had this idea, we had the design, but we had no idea if this will work at all, because it had to be real time, it had to be written in some kind of sane framework and render it quite nicely. So this was the prototype, and we made it. Let me see if this will work or not. I can scroll, but anyway, this works. This is all synced, all updated through Angular. This is rendered with Canvas. So this was like the first week of work, and not put inside the app itself, made completely outside of it. But after that, we know that okay, we can move forward because we made the prototype in like 2 days, and we know it won't blow up too often. Okay. And what's next?
I guess that's mine again. So when sprint 0 is complete, ordinary sprints begin. And this is a general scheme of how sprints work. Okay, first of all, of course, you should plan your sprint. Like, it's basically you sit in the one room, all of your team, and you go through all the tasks from backlog you have to this sprint, usually 2 weeks, in pretty much detail, like estimate everything more or less, like as much as you can precisely. Choose some functionally complete features that you can deliver this sprint. So then the development starts again. We will talk about this. Tymon will. Testing, deployment, then sprint review. Actually, I wanted to point it out that sprint review and sprint retro is quite important from PM point of view, but actually for developers it's like very useful too. So sprint review is when you show your client what has been done during these 2 weeks, and he approves or disapproves, so you have some feedback. And then goes sprint retro, which is internal stuff. You just gather your team together and you talk about what was bad, what was good during these 2 weeks, what you can improve, what you can, get rid of. It's kind of safe place to talk about what was going on these 2 weeks. So if you remember this funny circle when I talk about Scrum, so this is how it's represented by this scheme. So, okay. So how the development look like? Usually feature goes through some stages. This is a pretty much common case. It depends on project, of course, depends on the team, which way they prefer, but basically that's it. First you get new feature, then somebody start working on this, then somebody should do code review. Tymon will speak about it more detailed. When code review is done, so it's basically good refactored, we deploy it to staging, to test environment, and do some QA if needed. After that, it goes to client demonstration and could be approved or not approved, and then we deploy it. It's like basic one, so of course it could change. So when you have a lot of people in your project, it's hard to coordinate their actions. Actually, if you have if there one person like you just develop something, maybe it's easy to just keep everything in your head. But if it's more than 2, actually, that's pretty much difficult. So we use this tool called Jira. I don't know if you've heard of it. This is pretty much a good tool to track all these stages of feature development. It's agile oriented, so it's easy to keep Scrum thing there, and it's very flexible. It could be another lecture only about Jira, so just a few words. It's how it looks like. You just move these little squares from one stage to another. Okay. Okay, that's Tymon's part again.
Yeah. So basically, what happens with feature? And from the developer's perspective, getting back to this, feature is basically just a block. And I just came to office and click, okay, what should we do with this one? And first thing is to carefully read the feature spec. And this shouldn't be the first time that developer sees this feature, because it is already estimated and everyone agreed that it will take more or less that amount of time. But now this is the moment to read it very, very, very carefully and see if there are any issues and any more questions with that. Then is to verify prerequisites, which basically means that there might be some things that you need before you can start the development. For example, I don't know, we need to buy some cool JavaScript library because that's how the client works and wants it. Or we need account in some crazy API sandbox server because it costs $1,000 a day or something like this. I mean, it's not a fake situation, to be honest. And you need to, as the developer, it's I mean, like your responsibility to figure out those requirements and talk to PM as soon as possible before even starting working on this. Then here we have like 2 points. So it's like writing tests and writing code, and writing more tests and more code. And don't get too attached to this write tests first before writing code, and don't get also too attached to writing code and then writing tests. So as you may have noticed, the Ruby on Rails community is very keen on testing, on promoting test-driven development, behavior-driven development, whatever else driven development, but also connected to testing. In the real world, we need tests. They are very, very, very important, but it really doesn't matter that much what methodology you use, if you write first code then tests or the other way around. The point is that there need to be tests and there need to be code. And seriously, I mean, it doesn't really matter unless you don't forget about testing. So that's why I just put it like this. Then those tests need to pass locally. And this is the first sign that something might went wrong. But also developers tend to trick the tests so that they pass locally. And this is not because they have bad will, it's just how people work. And it's Friday, 5 p.m. and you just really want to go home. That's why we have another point here to tests, to ensure that tests passes on the continuous integration server, which should be very similar to your development machine, but in real world it's really different. And it's really a good thing that it's different because a lot of bugs can be just catched during this phase. And yeah, so basically when we have tests passed locally and passed on the CI server, we can say like, personally, I did this. And that's not true because this code has to pass the code review. And depends on project, of course, but the code review is usually a very tight process. I mean, we put a lot of pressure on it to ensure that the code is really, really good. And this is, of course, like for two reasons. One is that we want to have working code with no bugs as much as possible. Of course, 100% bug-free is impossible, but we try our best. Second one, we want to have code that's readable by everyone. So even if something works, there are tests, but the code looks like, edukacja. So we don't want this because a year later somebody will have to edit that, change something, and it will be a disaster. And then, I mean, the third thing really about code review is that people will learn. I mean, basically, you as a developer whose code is reviewed will learn from other developers that something might be done in a different way. So that's the code review, and we went through a lot of tools for that, but that's a different topic, I guess. And then there's this thing called staging, which we already mentioned. And the staging is basically environment for testing, for our internal testing. And this is really just a machine or just something that's where the app will live. And it should mimic the production environment as much as possible, but this never ever happened yet. I mean, I never heard of that since I'm doing this really. So it's always a little bit different, but this is the next stage of testing, really. And this is the place where our quality assurance people go and try to find some bugs. So that's on one hand for them, on the other hand for other developers to just see what's going on, for PM to see if something really is done, and also for customer to see, okay, this is the progress you're making this week. And you can imagine that when you work with multiple people on the same code base, let's say like two features and two different people at the very same time implement work on code base, implement those features, there might be conflicts, and it can even go to situation that after a sprint one feature is ready, the other one is not, and we really need to deploy something to production, but we can't push both of them because one is broken and all of that. And that's yet another reason for using Git. And we use feature branches for all the features. So here we have some master branch, something stable, and then from that we create a new feature branch that someone is working on. Not here. And from the very same point, from master, we create another feature branch, so they're just like diverging. And then when one of them is ready, we merge it into the master. So okay, now we know that the stable thing is also contains this new feature, and now we could safely deploy the master, so just the 456 feature without the first one. And if the first one is also ready, we just kind of like rebase it on the master and merge it again. So this is just a trick that first all to keep up with the changes from the feature that was finished earlier, because sometimes they just collide in some files like gem files, for example, if people change something. And the other reason is that we try to keep the history as clean as possible. So just not merge everything, but just to take some time and allow somebody after 2 years, for example, to backtrack what really happened with the code base. And I know it sounds ridiculous to look back 2 years, but it's really needed sometimes. So those small things like keeping the commit messages consistent, like using the Jira ticket number in the brackets, those small things just keep everything clean and help to backtrack into the past when needed. Other tools?
Like except for like GitHub, Jira, the tools. Someone mentioned what else we use during the development. Okay, so daily stand-ups. It's practically the meeting, like very short one, 10 or 15 minutes, not more. Just for the team to gather status, what's working on, who's working on what, what's the progress, like who has some blockers, what's going on. So it helps to keep everybody up to date. So nobody will, do something without other team members knowing. It's very helpful, actually. Okay, HipChat. That's as you can see from its name, it's basically chat with a lot of rooms, and it's very useful actually, because we have, for example, a room for every project, and this HipChat thing is integrated with all our internal tools like Jira, GitHub, Sentry, Circle, and whatever we use. So it's pretty convenient place to discuss every question raised during the development, because it's somebody could be out of office, that he could read it later. It's really useful to keep these conversations written down somewhere. So okay, and Harvest. That's basically more project management tool, but still, it's time tracker. So when you do something, you can track your time, how much you spend on it. So it helps to see how much, where's the most monstrosity time consumers. For example, if on the project is small, and filling out Jira takes more time than actual development, then it's useless, right? So actually it helps to improve estimations, because, for example, developers could estimate something in like hour, and it turned out to be 2 days. It's not like rare thing really. So it helps to see and be more careful in future, because you can show them, okay, 1 hour, you sure? So yeah. Actually, I don't know. Maybe I will mention, like, we have tools for checking the environment. It's like Sentry Circle, like stuff. Okay, Tymon will have.
There are more to come. Okay, so after some sprints, we agree that we want to do a release. And again, depends on clients. It can be like we do a release every single sprint, or we do a release every 2 months, because that's how we work. So this can be. I mean, the schedule is really, really depending on the project. But before the first release, this is the most important release, really. We need to prepare the app, and there are some non-obvious things that most developers mostly forget about. So first thing is error handling, and besides obvious things like we should handle some unauthorized access to this page, or when there is unexpected error, we should show this pretty page like we're sorry something went wrong. But this also means handling all the JavaScript errors, like you probably think that all the calls to the API from Angular app to the Rails, they will always succeed. No, they might not. And if you think about situations like internet connection lost, or just some lag on the network, or just that your internet provider said no, we will block this site, or whatever else, there will be errors. And a lot of apps just do not handle them correctly, and basically just do not handle them at all. So when something goes wrong, that was, let's say, I give like 99%, this will work always. It won't, unfortunately. So at least some global error handlers, like something went wrong in this app, you need to reload or revel. Of course, the best thing is to do is the one that you probably know from Gmail, like this yellow box, like I have lost connection, just wait, I will try to reconnect, all that stuff. And this is the de facto definition of single page app, that this app once loaded just lives in your browser, no matter if there is internet connection or not. But it's not always the case, unfortunately. One funny thing, because it's an issue almost on every first release, is like domain settings, or like email addresses settings. Like nobody ever changed that. Please change me email address at example.com. Never happened. So yes, I mean, it's just first day, come on. So all these local hosts, 3000 ports, hard-coded into the app, all of that needs to be cleaned. And sometimes it's quite a lot of them. Stuff like SSL, which is crazy because it's been there for like 20 years, but it's still an issue. Especially when you send an email with a link and you don't know if the production environment will have SSL or not, and then you have to somehow adjust to that, make some configuration option to either use the SSL or not. All of those little changes, and this is where the staging is really important, because you can have SSL on staging, you can have all the crazy domains on staging, and you can just test it there. Maybe not for the first release, but for some releases, caching. And of course, caching should only be done when there are performance issues. But caching is also tricky when you do a new release and something has changed, but everyone is still seeing the cache because it's cached. So like one thing is setting up cache, the other thing is clearing it before doing a new release. And minor stuff like minify assets, maybe take a look at your huge JPG files, maybe try to optimize them, do all of that stuff that will be downloaded into the browser. Maybe split the huge 5 megabytes application.js files into 2 because that's not needed on homepage. All that little things. And the next thing, so setting up the infrastructure. Nowadays, this is not really a developer's work. It's more of like someone will do this for me in the cloud because I pay a huge amount of money for this. Or there's this DevOps sysadmin guy in the basement that will do this. But I still think that developers should at least know what is going on. And the most important terms here is this PaaS versus IaaS versus bare metal, which basically means PaaS, which is the platform as a service, and this is really Heroku. So you just have an app and you just give it to them and magic happens and it's working. And so like full-blown platform for deploying applications. One level lower is the infrastructure as a service, which basically is a Amazon AWS. So you can just click button and okay, this is your virtual machine, do whatever you want. Someone still has to do the setup, but you get machine in seconds. And the lowest option, the bare metal, so maybe not actually going to the store and buying a physical machine, but kind of like renting a physical machine. And this usually takes more than a day or two to get a new machine in some data centers. So obviously the PaaS is the most expensive one. Bare metal is the least, but depending on the application needs, this is not obviously that simple. But anyway, in either of those options, you need to get possibly some database. So on Heroku, the PostgreSQL is for free. I mean, just a click of a button ahead. But on the other options, you need to set it up somehow. Think of the backups. Think of maybe some replications. What to do when the database goes down. What to do when we like fill up the disk storage. File storage, which is a tricky option when using the Heroku-like services because they usually don't allow you to store files. So we need to use some external service like Amazon S3 or Rackspace Cloud Files, something else. With virtual servers, you can use the file system, but most of the times those virtual machines have very small hard drives, so they fill up pretty quickly. So just remember about this. All this stuff connected with emails, so you don't probably want or either can on most of those platforms to use something like SendMail, just sending email, they will go to spam. So you need to have, the most sane option is to just get some external service that will send emails for you. They ensure that those emails go into the inbox, they do some click tracking, all of that fancy things. I mean, at this time there is no point in not using any of those. And also it's lagging. Some load balancing, because a single Rails app can handle in theory just one user at a time, and when there are many users, we need to handle them at the very same time. So load balancing the traffic until into multiple machines. again, some caching, queuing, putting stuff into the background, because something that took like 20 seconds on your development machine might take like 2 minutes because somebody just uploaded a 10 times bigger CSV file that nobody thought about before. So maybe not the best way to just lag on that and drop the connection. Stuff that happen periodically, like, I don't know, sending newsletters, sending some reminders, updating some stuff. It can be really anything. And this is mentioned here because during the development, those things are mostly just run using the console. Okay, I will run this. Hey, it works, so it will work. But no, you need to set it up, the scheduling. And after all that, not really. Because this is the thing that we need to do before we can say that the app was released. And then it's working and people start to use it and things will break. Definitely it will, because you can't just think of every possible scenario. So we need to be somehow prepared for that. And we had error handling before, but what to do with errors? We need some reporting. We need to know that 50% of our users are getting errors during the checkout process and they just don't buy stuff and all that things. So error reporting, a service that will just notify us developers about the errors. And this Sentry thing was already mentioned. So because we have the hip chat rooms, and when there is an error in the application, we just get a message in the chat, the red one, saying there is an error. You should take a look at this. Monitoring, but this is like a performance monitoring, stuff like New Relic, pretty expensive, but pretty awesome, really. It's especially for Rails app. It can give insights on how much time is spent when accessing database, how much time is spent rendering this view, how much time is spent just inside the Ruby itself computing some things. So really good insights about the production application performance. But those are like disasters, scenarios that we need to prepare for it. But at the same time, all these security updates that just needs to be done when there is new shell shock or some CV in the Rails itself. And also periodic gems updates, not really because of security, but just kind of like the maintenance work to keep the app fresh, let's say. And of course, bug fixing. And most of the bug fixing is either at the very beginning or after a very long time. And at the beginning, like everyone is just testing, and okay, we found this and that, we can fix it, and everyone, after a while, everyone is happy because it seems like we have fixed all the bugs. But then, a few months later, it turns out that there's this one user path that no one has taken before, and if there are this 5,000 different conditions happening, then there is an error. Those kinds of stuff are really hard to debug, and in those situations, of course, the good like logging, error reporting helps a lot. And this is probably not the most optimistic way to end this talk, but I guess this is like all. This is all true, obviously. And the good thing is that there is much more development than this support kind of stuff. I mean, it's usually, I'd say, like in terms of work, it should be like 3 months of developing features and just making them good, and then like a few weeks of bug fixing. You just compare this, and all of those. I mean, like maybe not all, but a lot of this support stuff is just done by external services or by platforms like Heroku, for example. Like error reporting, Sentry, done. It's just like a one-liner, and it's and it's there. Okay, do you have anything to add?
Yeah, just one important note that like why is that so complicated? Right? We have so many tools, we have so many processes. The truth is, nothing really happens according to plan. Never, like nothing. You can plan like a week ahead, small little week, and you're just totally sure that it will go okay, but it won't. So this is actually like a backup for you. So it's better to use it than to learn from your experience. It's better to use ours because we already did all these mistakes. And yeah, I guess that's it. So if you have any questions. Mhm. We usually work with time and material, but it depends, of course. Like, it depends on what you agree with your client would be the way it works. It's actually, there are debates about it, like eternal, but if you work in Scrum methodology, of course it's better to use time and material because it's more flexible. Things change and fixed price is not always a solution. So.
It's a really broad topic because every I can honestly say that every single project that we handle right now uses a different methodology. I mean, we have projects that are just at the very beginning, so there's just one small machine set up really quickly, and there's really no strategy. Just push the code, and that's it. And there are projects that are running on Heroku, so they are not. I mean, their strategy is just to deploy, restart, nothing more. And there are projects that we are just one of the teams that are working on it. So the deployment is handled by like 3 or 4 teams. So we need to synchronize with all that, and every team is using different tools. So it's all really complex, and of course we would like to use single tool for everything, but this will just never work. And if you want the names, so we have used like from Capistrano, Chef, Puppets, through Ensemble, our custom wrapper for Ensemble, basically, and of course Bash scripts, some handmade stuff. So, uh, this is a very good question because I'm a big fan of Docker, and we started to use it for development, not for like everyday development, but for example for designers, because performance of Docker file sharing on Mac is rubbish. Yeah, you need a virtual machine in the background, so different topic. It's just not there yet, but it's still useful. As it goes to deployment, compiled Docker image with a typical Rails app is around I don't know, like 500 megabytes or even 1 gigabyte if you don't strip down and compress gems and all that magic. So it's still faster in terms of network speed to just push code and deploy on the server. But in terms of like delivery, when you have like 2 nodes, you need the CDN for assets, for example. So we just do not compile it on every node, and and a lot of different things. Uh, Both, actually. I mean, have uh, we had a DevOps engineer full time, and we now don't need one really, to be We have one who's like, you can say he's full stack, but I'd say he's just like two persons in one body, like doing DevOps and doing the development stuff. But as the projects grow, more and more this infrastructure handling is taken outside, and this is mostly because we don't do like 24/7 support thing. So it makes sense to, when you need this kind of support, to have an external team that just handles the deployment, because they need to know the machines. So that's what we do basically. Any more questions?
Actually, one note on that.
Yep.
Like, even if you have the environment on client side and they do it, just don't relax, because you would need to have a lot of things from them, and you would need to talk to them, and probably it will be even more difficult than do it ourselves.
Yep.
So just you still need some person to handle this, like, just in case.
Yeah, and just like convincing somebody that yes, we really do need that error reporting stuff.
Yeah.
It's not the easiest thing to do.
And one more important note, I guess it's important. So what we described like this, it's like perfect scenario. It's like how it should work. It's theory. So, but in practice, it's never like that, of course. It's why the system is like the Scrum system, and what we described is good because it's flexible. So because never would ever work as planned. So yeah, and actually every slide, I guess it's topic on separate lectures. So yeah, I'll request to add them
for the next year.
Yeah. So any more questions?